there's a whole bunch of autonomous startups where they have a 5,000-watt server in their trunk, right? But that's because they think, well, 5,000 watts and $10,000 is okay because it's replacing a driver. Elon's approach was that board has to be cheap enough to put it in every single Tesla, whether they turn on autonomous driving or not.
So without, this isn't like confidential stuff, but you sitting on a porch looking over the world, looking at the work that Andre is doing, that Elon's doing with Tesla Autopilot, do you like the trajectory of where things are going on the hardware side?
They're making serious progress. I like the videos of people driving the beta stuff. Like, it's taken some pretty complicated intersections and all that, but it's still an intervention per drive.
Hey, I'm Steven and this is Solving the Money Problem. If you're new, welcome. If you're not, welcome back. So in this video, we're nerding out with legendary chip designer Jim Keller on Tesla's Autopilot and full self-driving software, deep neural networks, and Tesla's Dojo training system. So let's get into the video. But first, hey guys, if you'd like to help out the channel and get up to 2 free stocks, check out the link in the description to WeBull. If you open a new account, you'll get 1 free stock valued up to $250 just for opening an account. And if you fund your account with $100, you'll get a second free stock valued up to $1,600. Unless you don't like free stocks, that is. And if you're in Australia, the UK, or New Zealand, you can get a free stock with stake also using the link in the description. Let's get back to it.
Like the chips inside Tesla are pretty cheap. Like Mobileye has been doing this. They're doing the classic work from the simplest thing.
Yeah.
They were building 40 square millimeter chips. And NVIDIA, their solution had 2 800 millimeter chips and 2 200 millimeter chips. And, like boatloads of really expensive DRAMs. And it's a really different approach. So Mobileye fit the, let's say, automotive cost and form factor, and then they added features as it was economically viable. And NVIDIA said, take the biggest thing and we're going to go make it work. And that's also influenced like Waymo. There's a whole bunch of autonomous startups where they have a 5,000-watt server in their trunk, right? But that's because they think, well, 5,000 watts and $10,000 is okay because it's replacing a driver. Elon's approach was that board has to be cheap enough to put it in every single Tesla, whether they turn on autonomous driving or not.
So for those of you who don't know, Jim Keller actually worked at Tesla for a couple of years and worked on Tesla's hardware 3.0, so he's intimately familiar. And what a difference it makes if you ask the right questions. Instead of most of these companies thinking, oh, cool, well, how much is a human driver? Great, cool, so we can afford to spend $10,000 on the hardware, blah, blah, blah. Elon Musk and Tesla are asking a different question. How can we drive the cost of this technology down so far that we can include these full self-driving hardware chips in every vehicle, whether or not customers actually pay for the full self-driving software or not, whether it's inactive or active? And
Mobileye was like, we need to fit in the BOM and cost structure that car companies do. So they may sell you a GPS for $1,500, but the BOM for that's like $25.
Well, and for Mobileye, it seems like neural networks were not first-class citizens. Like the computation, they didn't start out as a...
Yeah, it was a CV problem. They did classic CV and found stoplights and lines. And they were really good at it.
Yeah, and they never, I mean, I don't know what's happening now, but they never fully pivoted. I mean, it's like, it's the NVIDIA thing. And then as opposed to, so if you look at the new Tesla work, it's like neural networks from the ground up, right?
Yeah, and even Tesla started with a lot of CV stuff in it, and Andre's basically been eliminating it. Move everything into the network.
So without, this isn't like confidential stuff, but you sitting on a porch looking over the world, looking at the work that Andre is doing, that Elon's doing with Tesla Autopilot, do you like the trajectory of where things are going on the hardware side?
They're making serious progress. I like the videos of people driving the beta stuff. Like, it's taken some pretty complicated intersections and all that, but it's still an intervention per drive. I mean, I have Autopilot, the current Autopilot, my Tesla. I use it every day.
Do you have full self-driving beta or no?
No.
So you like where this is going?
They're making progress. It's taken longer than anybody thought. My wonder is hardware 3, is it enough computing, off by 2, off by 5, off by 10, off by 100?
Yeah.
And I thought it probably wasn't enough, but they're doing pretty well with it now.
Yeah.
And one thing is the data set gets bigger, the training gets better. And then there's this interesting thing is you sort of train and build an arbitrary size network that solves the problem, and then you refactor the network down to the thing that you can afford to ship, right? So the goal isn't to build a network that fits in the phone. It's to build something that actually works. And then how do you make that most effective on the hardware you have? And they seem to be doing that much better than a couple of years ago.
Things sounding very positive there from Jim, who was initially skeptical that Tesla's Hardware 3, which is currently in all Tesla vehicles rolling off production lines, has been for a couple of years now, whether or not they would actually have enough compute. But he seems very impressed with how well it's handling the software at the moment. Very positive signs.
Well, the one really important thing is also what they're doing well is how to iterate that quickly, which means like it's not just about one-time deployment of one building. It's constantly iterating the network and trying to automate as many steps as possible, right?
Yeah.
And that's actually the principles of the software 2.0, like you mentioned with Andre, is it's not just, I mean, I don't know what his description of software 2.0 is, if it's just high-level philosophical or there's specifics, but the interesting thing about what that actually looks in the real world is it's that what I think Andre calls the data engine. It's like, it's the iterative improvement of the thing.
Yeah.
You have a neural network that does stuff, fails on a bunch of things, and learns from it over and over and over. So you're constantly discovering edge cases. So it's very much about like data engineering, like figuring out. It's kind of what you were talking about with TensorTorrent. Is you have the data landscape. You have to walk along that data landscape in a way that that's constantly improving the neural network, and that feels like that's the central piece that they're trying to solve.
And there's two pieces of it. Like you find edge cases that don't work, and then you define something that goes get you data for that. But then the other constraint is whether you have to label it or not. Like the amazing thing about like the GPT-3 stuff is it's unsupervised.
Yep.
So there's essentially infinite amount of data. Now there's obviously infinite amount of data available from cars of people successfully driving. But you know the current pipelines are mostly running on labeled data, which is human limited. So when that becomes unsupervised, right, it'll create unlimited amount of data, which then they'll scale. Now the networks that may use that data might be way too big for cars, but then there'll be the transformation from now I have unlimited data, I know exactly what I want. Now can I turn that into something that fits in the car? And that process is going to happen all over the place. Every time you get to the place where you have unlimited data, and that's what software 2.0 is about, unlimited data training networks to do stuff without humans writing code to do it.
So for those of you who don't truly understand the distinction between software 1.0 and software 2.0, effectively the key difference here is software 1.0 programmed by human programmers to a specific solution. It is hard-coded to solve a specific problem, whereas software 2.0, it's really just trained with a ton of data and eventually will learn how to solve problems and come up with similar solutions without a human actually needing to specifically code the software to specifically achieve a specific goal. The key here is whether or not this data needs to be labeled, and my understanding is that Tesla's trying to remove as much of this human labeling as possible, ultimately getting to a point where no labeling is necessary, and then, as Jim says, you have infinite data. If you remove the need for human labeling, things are going to absolutely snowball from there. This is Tesla's end game, to get to a point where they can feed in an unlimited amount of data without needing human labeling.
And ultimately also trying to discover, like you're saying, the self-supervised formulation of the problem. So the unsupervised formulation of the problem. Like, you know, in driving, there's this really interesting thing, which is you look at a scene that's before you and you have data about what a successful human driver did in that scene, you know, 1 second later. It's a little piece of data that you can use just like with GPT-3 as training. Currently, even though Tesla says they're using that, it's an open question to me. How far can you solve all of driving with just that self-supervised piece of data? And like, I think
well, that's what Common AI is doing.
That's what Common AI is doing. But the question is how much data. So what Common AI doesn't have is as good of a data engine, for example, as Tesla does. That's where the organization of the data. I mean, as far as I know, I haven't talked to George, but they do have the data. The question is how much data is needed. because we say infinite very loosely here.
No.
And then the other question, which you said, I don't know if you think it's still an open question, is are we on the right order of magnitude for the compute necessary?
Yeah.
That is it like what Elon said, this chip that's in there now is enough to do full self-driving, or do we need another order of magnitude? And I think nobody actually knows the answer to that question. I like the confidence that Elon has, but
yeah, we'll see. And there's another funny thing is you don't learn to drive with infinite amounts of data.
Right.
You learn to drive with an intellectual framework that understands physics and color and horizontal surfaces and laws and roads and, all your experience from manipulating your environment. Like there's so many factors go into that. So then when you learn to drive, like driving is a subset of this conceptual framework that you have, right? And so with self-driving cars right now, we're teaching them to drive with driving data. Like you never teach a human to do that. You teach a human all kinds of interesting things, like language, like don't do that, watch out, there's all kinds of stuff going on.
Some super interesting points here. I know we're getting down in the weeds a little bit. Hope the nerds like it. Everyone else, see you in the next video. I know it might be a little bit much to handle, but understanding the fact that human beings don't learn to drive by just being given data about driving situations. We already have a fundamental intuitive understanding of physics. We learn this stuff as toddlers. Some of it's sort of innate. Other stuff we learn very quickly by experimenting. We know as a baby, if we push something off the edge of a table, it is going to fall on the ground. We understand the concept of gravity. We understand many other things like this as well. So when it comes to actually learning how to drive as a human being, we're not being fed a bunch of situations and scenarios about driving and learning based on that. We're using a lot of the fundamental understandings we've built up as being a human over our lifetimes, how the world works, the way things are. And then when we're actually trained on how to drive, we'll have a driving instructor there, whether it's parent or professional, telling us certain things verbally. Don't do this, that's dangerous, slow down, these kind of things. So as human beings, we learn to drive quite differently. We still use a visual system and a neural network, but the actual process for training there is a little different.
Well, this is where I think previous time we talked about where you poetically disagreed with my naive notion about humans. I just think that humans will make this whole driving thing really difficult.
Yeah, all right. I said humans don't move that slow. It's a ballistics problem.
I tend to side with Jim Keller on this point. I've been listening to Lex's podcast since episode 1. I'm a huge fan. I've noticed Lex has a tendency to romanticize things. He just can't help himself. I think he may be doing that in the case of human beings as well. If we think about this logically and rationally, it really is a ballistics problem at the end of the day. If cameras can take in information at a high enough frame rate and then act on that information quickly enough, it doesn't really matter the motivations of the object moving, right? It's just, okay, let's avoid this thing. Now, I totally understand having a layer of awareness as a human being, realizing, for example, okay, that person's walking really wobbly. They're probably drunk. I should probably slow down and give them some extra space in case they do something moronic, like walk out or even stumble or fall in front of my car. Self-driving AI may not have that same level of cognition, but that doesn't necessarily matter. It's able to take in information quickly enough and then respond quickly enough. It really is a ballistics problem at the end of the day. Doesn't matter whether it's a tree falling, a drunk human stumbling, or something else.
Humans are a ballistics problem, which is like poetry to me. It's very possible that in driving they're indeed purely a ballistics problem. I think that's probably the right way to think about it. But they still continue to surprise me. Those damn pedestrians, the cyclists, other humans in other cars, and
yeah, but it's going to be one of these compensating things. So like when you're driving, you have an intuition about what humans are going to do, but you don't have 360 cameras and radars, and you have an attention problem. So so the self-driving car comes in with no attention problem, 360 cameras, right? A bunch of other features.
Yeah.
So they'll wipe out a whole class of accidents, right? And emergency braking with radar, and especially as it gets AI enhanced, will eliminate collisions.
Yeah.
Right. But then you have the other problems of these unexpected things where, you think your human intuition is helping, but then the cars also have, a set of hardware features that you're not even close to.
Great points there from Jim. I think a lot of people tend to overlook some of the hardware and software differences between a computer vision system and a human driver. Now, human drivers, of course, we don't have surround cameras, so there's that massive disadvantage. We don't have radar, so we can't see through objects, also a massive disadvantage. We also can't react as fast as a computer, also a massive disadvantage. And then there's the attention problem. Not only do we get distracted and tired, I mean, guys, let's be honest, and I do know some women are watching as well, but according to my statistics, it's about 94, 95% dudes. Talk about a sausage fest, but it is what it is. Anyway, you probably know where I'm going with this. If you see a stunningly attractive woman anywhere in your peripheral vision while you're driving, what are the odds that you're actually going to take a peek? Extraordinarily high. Unless, of course, there's something wrong with your brain, and I actually mean that. We are evolutionary wired to constantly be looking for fertile potential mates. It is what it is. Facts of life. Sorry if I melted any snowflakes, but these are the facts. And yes, that also includes when your girlfriend and or wife is in the car. You'll just be a little bit more sly about it. So the point I'm making here is human beings are very complicated, messy, and prone to distraction. They have tension issues. We get tired. We get fatigued. We glance here. We look here. We don't look here. These kind of things. This will not be a problem we'll face with self-driving computers.
And the key thing, of course, is if you wipe out a huge number of kind of accidents, then it might be just way safer than a human driver, even if humans are still a problem. That's hard to figure out.
Yeah, that's probably what will happen. Is autonomous cars will have a small number of accidents humans would have avoided, but they'll get rid of the bulk of them.
What do you think about like Tesla's Dojo efforts, or it can be bigger than Tesla in general? It's kind of like the tense torrent, trying to innovate. Like, this is the dichotomy. Like, should a company try to from scratch build its own neural network training hardware?
Well, first, I think it's great. So we need lots of experiments, right? And there's lots of startups working on this, and they're pursuing different things. You know, I was there when we started Dojo, and it was sort of like, what's the unconstrained computer solution to go do very large training problems?
Yeah.
And then there's fun stuff like, you know, we said, well, we have this 10,000 watt board to cool. Well, you go talk to guys at SpaceX, and they think 10,000 watts is a really small number, not a big number.
Yeah.
And there's brilliant people working on it. I'm curious to see how it'll come out. I couldn't tell you, you know, I know it pivoted a few times since I left. So
the cooling does seem to be a big problem. I do like what Elon said about it, which is like, we don't want to do the thing unless it's way better than the alternative, whatever the alternative is. So it has to be way better than like racks of GPUs.
Yeah. Right. And the other thing is, just like, you know, the Tesla autonomous driving hardware, it was only serving one software stack. Mm-hmm. And the hardware team and the software team were tightly coupled. You know, if you're building a general purpose AI solution, and you know, there's so many different customers with so many different needs. Now, something Andre said is, I think this is amazing. 10 years ago, like vision, recommendation, language were completely different disciplines. Mm-hmm. He said the people literally couldn't talk to each other. And 3 years ago, it was all neural networks, but the very different neural networks. Mm-hmm. And recently it's converging on one set of networks.
So the implications here are kind of crazy. 10 years ago, vision, as in image recognition, language, and recommendations, for example, Amazon product recommendations, YouTube video recommendations, etc., all driven by completely different software solutions. Then 3 years ago, all of these were operating on neural networks, and today they're converging towards the same neural network. This is insane. Now, for those of you who didn't catch my recent video on deep learning and the $30 trillion opportunity, I'll put a card in the corner. I really don't think most people are understanding the implications here. Deep learning, neural networks are going to completely transform and disrupt every aspect of our lives. ARK Invest believes by 2037, around 15 years, they will add an additional $30 trillion of market capitalization in the stock markets. And now to bring this back to Tesla, we can start to see the implications here. Tesla has cutting-edge neural networks working on computer vision and solving fully autonomous driving. This is a huge opportunity. One of the many reasons I think over the last 12 months, Tesla stock is headed towards the moon. The stock market is starting to recognize how significant this is.
They vary a lot in size. Obviously, they vary in data, vary in outputs, but the technology has converged a good bit.
Yeah, these transformers behind GPT-3, it seems like they could be applied to video, they could be applied to a lot of, and it's like, and they're all really simple. And
it was like to literally replace letters with pixels.
Yeah.
It does vision. It's amazing. So
And then size actually improves the thing. So the bigger it gets, the more compute you throw at it, the better it gets.
And the more data you have, the better it gets. So then you start to wonder, well, is that a fundamental thing, or is this just another step to some fundamental understanding about this kind of computation, which is really interesting.
Us humans don't want to believe that that kind of thing will achieve conceptual understanding, as you were saying. Like you'll figure out physics, but maybe it will. Maybe.
Probably will. Well, it's worse than that. It'll understand physics in ways that we can't understand.
What a great place to wrap up here. Jim Keller, quite confident that over time, neural networks will develop a deep conceptual understanding of physics that goes far beyond what humans are capable of understanding. And for anyone who's ever attempted to understand quantum physics, you'll see where he's coming from here. I know this was a super nerdy video. I hope you guys enjoyed it. I really want to emphasize how incredible Tesla's progress is in terms of solving full self-driving, how close they appear to be, and how far in front of everybody they are who's working on this problem. Mark my words, Tesla will be the first company to solve fully autonomous vehicles, and it's likely that they'll get to a situation where people attempting to catch up to Tesla will just throw their hands in the air and go, you know what? Fuck it. We're just going to license this from Tesla instead of spending 3 to 4 more years trying to solve this problem. Hey Tesla, how much is it going to cost for us to license your software? Mark my words. And just finally, before we wrap up, let me know in the comments below your exact guess. What year and what month and what day will Tesla first, somewhere on Earth, deploy a fully autonomous vehicle that does not require human supervision? Whoever has the closest guess gets absolutely nothing. I'm Stephen Mark Ryan, this is Solving the Money Problem, and I love you all. And don't forget, if you'd like to help out the channel and get up to 2 free stocks, check out the link in the description to WeBull. If you open a new account, you'll get 1 free stock valued up to $250 just for opening an account. And if you fund your account with $100, you'll get a second free stock valued up to $1,600. And if you're in Australia, the UK or New Zealand, you can get a free stock with stake also using the link in the description. Thanks so much for watching. Let me know your thoughts in the comments below. And of course, if you have any ideas for future videos, let me know. I read all your comments. P.S. If you're still watching, you're awesome. If you'd like early access, exclusive videos, regular Q&As, our private Discord server and more, consider supporting the channel at patreon.com/solvingthemoneyproblem so I can keep creating content for you guys. There's a link in the description. You can now also become a member of the channel for some exclusive perks. To learn more, click the join button next to subscribe. And don't forget to check out our merch store. Either way, the best form of support is you being here and watching, so thanks again.